So let's say they ask you to find the value of x in this case for 6 marks. Now, the first thing you realize is that you are dealing with rational exponents. In other words, your exponents are fractions. And furthermore, you see this is a trinomial, the last term of which is a constant. So it has no variable assigned to it. So in such cases, I want you to think of a quadratic equation. Now, the first thing you do, you check what is the relationship between half and 1/4. Then we can see that half is twice as much 1/4. So because we see that, we are just going to write x to the half in terms of x to the 1/4. So it's going to be x to the quarter, which is all squared. You didn't change anything. If you multiply these two, you still get the half there. Then this one, you write it as it is. The same holds for the last term. In order for you to simplify this, let's use the k substitution method. So we end up having k squared minus k minus 2. And this is equal to 0. So in order for us to solve for k, we have to factorize this. So these are factors of k squared. Factors of 2 that add up to 1, it's 2 and 1. And the bigger number takes the sign of the middle term. So it means our k has to be -1, or it has to be +2. But what is k? Well, k is x to the quarter, and we say this is equal to -1. But now here we see there is no solution. There is no value of x, which if we take and raise it to an even power, will result in a negative exponent. No. Right. Then let's focus on the last part. So you say where you see k, you actually see x to the quarter, and then you say this is equal to 2. So in order for you to solve for x, you have to raise both sides to the reciprocal of the exponent. So which is 4 in this case. So that 1/4 times 4, it's 1. So you end up having x to the power 1, which is just x. And 2 to the power 4, it's just going to be 16. And then you should be happy and done with this one. So in order to make sure you understand this concept, let's do another question. I think for these ones, we'll do 3 questions. That should be it. You should be fine. Right. Now this one says it's x minus 2 square root x. And then you say -8. This is equal to 0. So this one is worth 5 marks. Solve for x once again. Now, before we do anything, let's get rid of this square root. So we understand that square root means something raised to the power half. Then from this point, we see it's a trinomial, and we see that we have a rational exponent, right? And the last term is a constant. So we are trying to generate a quadratic equation. Now the exponent of x is 1, we understand. Then we say, what is the relationship between 1 and half? Then we understand that 1 is actually twice as much half. So the moment we see that, we are going to write x to the power 1 in terms of x to the half. So it's going to be x to the half, which is all squared. You didn't change anything. Then you still say minus 2x to the half minus 8. And this is equal to 0. Then once again, we use the k substitution method. So we say, let's allow k to be x to the half. So this is going to be k squared minus 2k. Then you say minus 8 like this. Then we go on and factorize here. So we say factors of 8 that add up to 2. It can only be 4 and 2. And of course, factors of k squared, it's k and k. So the bigger number takes the sign of the middle term, and this one has to be positive. So it means the values of k will be negative 2, or k will be positive 4. But now we know that k is actually x to the half, which is equal to negative 2. And we see that there is no solution for this one. There is no value of x, which if we raise to an even power, will result in a negative answer. We don't have such. Then we go to the second part. So we say k is actually x to the half, and this is equal to 4. But in order to solve for x, we have to raise both sides to the reciprocal of the exponent, which is 2 in this case. So you'll have x, and then 4 squared once again will just be 16. And then you should be happy and fine with this one as well. But in order to complete your happiness, I think your happiness is complete with these two, but this one is a little bit advanced, not really advanced. It's ordinary, just that we'll have to factorize the advanced quadratic equation. That's the only thing that makes it special. Otherwise, it's the same as the first two. So we are doing this one for the sake of practicing together. But it can never get worse, guys. It's always like this. What is the relationship between the exponent of the first term and the exponent of the second? If it's twice as much, it's a quadratic equation. You write the first term in terms of the second term, or the middle term if you like. And then you are done. Right, so this one says it's 3 square root x. Then you say minus 5x, which is raised to the 1 over 4. And then you say minus 2. And this is equal to 0. It's 5 marks as well. Now, the first thing we do here is to get rid of the square root. So we say square root means something raised to the half. And then we have 5x raised to the quarter. Then you say minus 2 equals 0. So we see this is a trinomial. The last term is a constant. So we are thinking of a quadratic function, or sorry, equation. But in order to verify, we say, what is the relationship between half and 1 over 4? Then we see once again, it's twice as much 1 over 4. So because of that, we write x to the half in terms of x to the quarter. So it's x to the quarter, which is all squared. And then we say minus 5x to the quarter minus 2. And this is equal to 0. Then once again, we introduce the k substitution method. So we say k will be x to the quarter, so that in its simplest form, it's going to be 3k squared minus 5k minus 2. And this is set equal to 0. So in order for us to factorize, we have to go and use a table where we list factors of the first term and of the last term. Because here we see that the coefficient of k squared is not 1. So it's a little bit advanced. So 3k squared, we can write it as 3k times k. And the last term, which is 2, can only be written as 2 times 1. So we are looking for a combination of multiplications such that if we add them, we should get 5. So if you say 3 times 2, 3k times 2, you get 6k. And if you say k times 1, you get k. So we see that 6k minus k will be 5. So it's a perfect combination. So I'm saying 3k will be multiplied by 2 so that we get 6k, and k will be multiplied by 1 so that we get k. But in order for us to get negative 5k, it means this one has to be negative and this one has to be positive. So this is our first factor, and this is our second factor of this quadratic equation. So we open 2 brackets here. We equate everything to 0. So we have 3k and 1. Then we have k and 2. So the sign of the first factor will be positive. The sign of the second factor will be negative. After applying your 0 factor law, you find that k equals negative 1 over 3, or k equals 2. But what is k? We said k is x to the quarter, which is equal to negative third. So once again, there is no solution for this one. But if we go to the last part, we still have x to the quarter, which is equal to 2. Then we raise everything to the power of the reciprocal of the exponent. So once again, the value of x will be 60. Why are these values all 60? I'm not sure. But yes, this is how you should take care of equations that have rational exponents. So they look scary at first glance, but if you give them a good look, you see that I know they are not so intimidating after all. But this should be the end to this video. Thank you so much for watching.